Okay, welcome to another week. All right, so finally something new. So it's not like functions where, we kind of saw them before, we just saw them in a slightly different way. This time I know that in infs1201 they absolutely do not cover lists and it doesn't actually belong there, so it's good that they don't. Which means that, we're finally covering new things. We're slowly pulling the new stuff back a little bit earlier, so if you're saying, hey, that means that we just spent 4 weeks kind of doing review, well actually maybe you spent 2 because the other stuff was new. All right, but in any case, off we go. List basics. So we better have ourselves a problem as usual. It'll probably be just 1 or 2 slides here. We'll do a bunch of stuff through code, but I am covering all the stuff in the slides. All right, so list. All right, it is basic. So this is the easy stuff of lists. Unfortunately, yes, it's at this point where things start to become a little bit challenging. Okay, probably to say it lightly. If we think back to what we learned in INFS 1101, and I say, okay, basic input, output, no ifs, no whiles, everybody will say, yeah, I can do that. All right, I throw in an if statement, it's also okay. However, as soon as I put in loops, that's where it all starts to fall apart. Because at this point, you're dealing with patterns of things. And unfortunately, to deal with lists, you generally are also dealing with loops. So as a result, lists are going to be tricky stuff. However, they're really, really critical. All right, so a couple sections of the textbook. All right, here's a situation. We've asked you to do things like this before. Enter a bunch of test scores and calculate the average. Okay, good. Yeah, you can do this. Enter 100 test scores and tell me which is the highest and lowest. Yeah, you can do that. Okay, and you can even make it so that it's flexible, so that sometimes you enter 5, sometimes you enter 50. You can set it up so that it terminates when you enter a -1. That's great. However, what do we do if I said, hey, I want you to enter 100 test scores and I want you to show me the top 10 scores? Okay. That's not exactly something that you would want to do without a list. Okay, now, if you might say, yeah, but you know what, I can make 100 variables. Sure, we could have a variable called test1, test2, test3, test4. In fact, right there, what I've done is I've set up 4 variables with different scores, and the piece of code that I just wrote will preview the highest. However, there's a bit of a limitation on this is what happens if there's 100? No problem, I can copy and paste. And if you say nobody's going to do that, trust me, I've seen students in intro courses try this before. They say, oh, it's only 100, I can copy and paste that. And I've actually seen them attempt this. Obviously, it's probably not the right way to do it. Okay, however, a list, on the other hand, happens to be a way that we can store multiple things at the same time in the same variable. So one variable with a whole bunch of things. So I think we'll do one extra slide, then we'll actually start on this. Okay, and I'll put it away and we'll actually do some work. So what is this thing that I'm talking about called a list? All right, so you can see an example at the bottom, but I'd rather be more interested in the first couple of bullet points. First thing up, it says that it's an ordered collection of items. Okay, so mathematically that is correct. However, we'd better have a couple of words that we have to explain. All right, first word up is the word collection. Collection simply means that you have more than one. You see, what we've been doing, say back here, test number 1, how many values is in the variable called test1? Yeah, just 1, and the value happens to be 70 because of what we've said here. Okay, on the other hand, you can see at the bottom I have made a collection. Okay, it happens to be a list, and I'll explain what makes it a list in a minute. But how many values do you think that test scores contains? And that's valid Python, by the way. Yeah, that's exactly it, okay? So even if I don't say, hey, but that's kind of a quick way to look at it and say, hey, it's a variable that stores 4 things. Yeah, actually, it's not that far of a stretch because you have been used to dealing with stuff like this. Strings happen to be a bunch of characters, okay? So test scores is just a bunch of scores. All right, so that's the first thing up. Second thing, I guess that was the second thing. First thing, ordered. What does the word ordered mean? Okay, the word ordered has a couple of very important realizations that comes along with it. When you have something that is considered to be ordered, we're talking about that when you put things in a particular place relative to other things inside the collection, they stay in the same location. Okay, it's a big, long word. There's something else as well, and that is there's always something that starts the collection and something that ends the collection. Ooh, okay, so we better put this in a context. It's for the example that I provided down here. So everybody said, yeah, there's 4 items. Okay, excellent. Out of the 4 items, what do you think comes first? Yeah, that's a pretty good guess. You're absolutely correct, by the way. It's not a trick question. I know you're used to trick questions from me, but yes, that's exactly what comes first. Is there an element in this collection that we would consider the last? 75, yeah, because, well, it's at the farthest right-hand side. That's exactly it. All right, if I ask you the number 80, okay, can I ask you what comes just before 80? Okay, and can I ask you exactly what comes just after 80? 60. Okay, so it's pretty easy. So this is what the word ordered means. It means that there's a definite start, there's a definite end. Every element inside has something that comes before it and after it. Of course, unless you're at the ends, of which you have nothing before or after those 2 extremes. All right, so pretty straightforward. That's because I have to say this because there are unordered collections that we will see. Okay, another important thing is if I put this away and I say, okay, this is what the variable has. It has 70, 80, 67, and 75 as a list. I put it away and I bring it back 5 days later, if the program is still running, the order of the elements will be exactly the same. Okay, they don't suddenly pop up and jump around and move into other places. There are data structures that work like this. This is not one of them. Okay, that's an unordered collection. All right, so there we go. It's an ordered collection. Python lists can hold any type of items, including a mixture. The program is a lot easier if they're all the same type. And it says that you can access, change, and iterate through all the items. Okay, well, that's really the whole lecture. So let's put this away. And what we will do is we'll start some examples over here. All right, there's a candidate for the final exam, but I've decided no. I mean, it is a possible program. I'm never going to ask it, but hey, it is. I always do this just to make sure things are working. All right, so here we go. Test scores is what I just had. So we had a 70, we had an 80, we had a 67 and a 75. Okay, so what can we do with this? Well, it says there that you can access, change, and iterate through the items. All right, so no functions today, by the way, because we've got, lists are kind of weird enough on their own. No functions, but I promise they will come back. I suppose one thing that we probably want to ask is, okay, if somebody tries to print the scores, what do we see? Okay, well, the good news is that if you try to print a list, okay, and by the way, this is a list, it looks like this. Okay, and that's pretty decent. All right, usually at this point, somebody will start to ask questions like, hey, what happens if I leave out those square brackets? Can I do this? And the answer is surprisingly, yes, you can, but you get something a little bit different. Okay, oh, I remember, sometimes I do this as well. I will tell you the type of the scores. If you leave it out, it looks an awful lot like a list, but it isn't. It's actually something called a tuple. We'll come back and we'll see the tuples later. So the fact that you have the square brackets around it, this is the thing that makes it a list. Okay, and this is what we're working on, not tuples. Tuples we'll come back to. It's another type. It's kind of like a list, but it's got some extra properties we have to deal with, but this happens to be a list. All right. And every time, if I run this program 100 times, if I print out all of the items or I call the print statement a bunch of times, the list will always be exactly the same. It will look exactly the same because it is an ordered collection. All right, now, next thing up. So it says you can access, change, and iterate. Well, I better do these one slide at a time. So I'll be doing this stuff on the slides, making sure that I've done the same things. All right, so access. Okay, what do you mean by access? Okay, first one up is you can just print everything. And if you happen to have ever taken a programming course in, say, Java, you might look at that and go, I know you can't do that. You see, some languages you can't actually print the equivalent of a list, but in Python, it's really helpful. You can just print it. All right, however, sometimes we're not interested in printing the entire thing. We might be just interested in dealing with one particular value. Okay. In order to access, we've seen square brackets before, haven't we? Where did we see square brackets? Yeah, we saw it in slicing, which was related to strings. All right, I hope you remember that one of the items that you could do, the simplest form of slicing, well, not even slicing, is you can go and you can put in a single value. Okay, so what this is doing, it works exactly the same way as a string. So if this was a string and I said test scores at square brackets 2, I would end up seeing one character. Okay, but now that I've got this, that's exactly what's going to happen. It's going to show me the value 67. It's indexed exactly the same way as a string. The very first element is at position 0. Okay, there you go. If you're looking for the very last element, yeah, lucky this works. Okay, and I have to say lucky because if you happen to be in the INFS program or any of the courses that take, or any of the programs that take our JavaScript course, it doesn't work there. Okay, just keep that in mind. But for Python, it works perfectly fine. And yes, this will end up giving me the very last element. That's a 75. So at least it kind of matches the same idea what we ended up seeing before in the world of strings. However, there's some more things that we can do which are very, very interesting in here. All right. This is a very, very important property. If I can type, it'll be even better. Again, if I can type, here we go. All right. Remember, we tried this with strings once because we realized that you could put a square bracket and you could access a single character, but if you tried to actually modify a character, it blew up and said, yeah, assignment not permitted. All right, so is it the case here? And the answer is no, it's a little bit different here. So what you can do in the world of lists is you can go and you can actually modify items directly. Okay, so you don't have to make a new string like what we were doing before with slicing and concatenation and so on. You can actually just go ahead and modify items directly. I saw a couple of people in the lab yesterday trying to do something similar to this because of the very first programming exercise question where somebody was trying to modify the characters to be stars. So if you haven't been in the lab, you'll know what I talk about when I get there. And it turns out you can't do that. But if it had been a list, yes, you can do these things. All right, so yeah, you can go ahead and you can modify anything. If I were to do this, what's your prediction? Yeah, it'll change to 75. Okay, so we'll just double check that one. Yeah, that's fine. And let's see, another way to mention this one, if I said 4.
Sorry, the same result.
Exactly the same result. Okay, well, we better clear the screen if it's the same result. No, it's an index out of bounds. Okay, thank you for saying that. I think I heard somebody else. I was just waiting for somebody to say the wrong thing, so thank you. Okay, no, it's not meant to be fun, but if people have this, if one person says, there could be somebody else thinking it, and we need to expose it. All right, so yeah, it's the same idea. You can't step outside of the allowable range. Okay, but this thing right here, this is a very, very important property that you can modify things. Well, sorry, not this one, sorry. But you can modify valid locations. Okay, that will modify the very last one. And this, even though it says the word right here, I'm not quite in the right position to describe it yet, but it does say that lists are mutable. Oh, okay. I can't describe the word yet. I really should fix up the slides so that the word mutable shows up at one point and we actually spend a lot of time dealing with it. All right, but basically you can think about the word mutable as, yeah, you can change what's inside without having to build a brand new list. Yeah. Oh, we'd like to add something to the end. Well, unfortunately, only if I turn the right page and I actually see it here. Okay, I think it's coming. Okay, and that's a reasonable thing because, okay, we've got how many test scores right now? 4. Maybe it would be useful if I had a couple more because I seem to have more students. So how do we do that? And yeah, I think it's coming up on a slide maybe next. Not quite, but almost. All right, the very next slide. Oh, okay, very important. Okay, this is always the danger if I change this. Okay, here, let's run it because somebody will say, wait a minute, how is that an error? All right, here you go. There's the output. I won't touch it. All right, what type of error is this? We better know. It's an index error. Okay, so the word index simply means that you're accessing something which is beyond the length of the list. Okay, and my apologies if I ever call this an array in this course. Sorry, I mean the word list. Okay, in Java we don't use the word list, we use the word array. So sometimes I mix the two up, but I always mean a list. All right, so so if we have things like this, okay, the ability to access things, well, let's go through and start writing some little programs to do things. All right, first one up is I'd like to print all of the test scores. Now you'll say, yeah, but all I have to do is just do print. All right, let's do it this way. Let's print all of the test scores, each score on a separate line. Okay, so in other words, I can't just do print test scores. I can't do this because it prints horizontally in one thing. But if I'm talking about a 70 followed by an 80 followed by a 67 followed by a 75, different lines, the reason why we might want to do that, okay, it'll be coming up here, I think it's the next slide. Maybe we have to modify some of the grades, or maybe we don't want to print all of them, we just want to print some of them, okay? So this on its own is not quite good enough. All right, so what can we do? Okay, a very, very common thing that we will end up doing is we will use indexing. And I have used indexing before in strings to print out individual characters exactly the same way. And if you're saying, hey, but there's a quick, we'll get there. All right, you see the very first index that I have on test scores is 0. Okay, that of course means the location. So sometimes I use the word POS for position, but I will use it as index. What I'm going to do is I'm going to set up a while loop to say, well, the index is less than or equal to, I'm going to fix a bunch of this stuff. What's the highest index that will work? So when I say test scores, square bracket, and put a number, what's the biggest number I can have? 4? 3, remember it's always one less than the end. There are 4 elements. First element is 0, which means the last element is 1 less. All right, less than or equal to 3. Okay, I will come back. We'll fix this. It's not really the best option yet. Here we go. What I'm going to do is I'm going to print this. I'm going to say the test score was. Ooh, now how do you pick up the test score? Well, remember, I've got a list. For me to pick up one element, instead of printing the entire test scores, what if I just ask for the thing that's at position index? Okay, I'm sorry, that's just going to go off the end just a little tiny bit. All right, there we go. So what's this going to do is that's going to print position 0. All right, but of course then what I'm going to do is I'm going to say, well, index goes up by 1 each time. Okay, so notice what I'm doing. The value of index goes from 0 to 1 to 2 to 3, and then the whole program stops. And what am I printing? I'm printing test scores at the index. Okay, and here, let me get rid of that so you can see the whole thing. Okay, eventually I stop printing messages. Okay, but here you go. There are the individual items. Okay, now, why would I possibly want to do things like this? Okay, let's add a few extra test scores. Okay, so here we go. Let's put in some, maybe not some good test scores. Okay, a better test score, maybe another not so good test score, maybe a couple of 50s at the end. Okay, there we go. Now we've got a few more tests. How many scores do I have in total?
9.
Okay, 9, that's not a very good number. All right, here. All right, how many do I have now? 10. Okay, 10. Oh, I can't quite see them. All right, no problem. If you can't quite see them, you have a lot of flexibility, and that is you can press an enter here, and maybe what I'll do is I'll put an enter here and I'll put an enter here. This is all valid Python. Okay, and sometimes I will do this. If I've got a really long list of things and they simply go beyond the screen, I'll just press enter a few times. They don't have to be exactly in the right shape. You can press enter after each one. You can press enter at the break point, whatever you want. But quite often I will present them this way so that it's easy to match up, because this I can now very quickly figure out, yeah, there's 10 because I see 2 rows of 5. Okay, all right, so, all right. Oh, that program doesn't work, does it? I guess that's probably our first thing. How many values am I seeing? I'm only seeing 4, but how many things are supposed to be shown? It's supposed to show 10. Well, it kind of makes sense, because if you look right here, that's hard-coded the number 3. which means that it doesn't work for my new list. And to make it work, I would have to change it to 9. Okay, there you go. Am I showing everything now? Yeah. Okay, now, here's a bit of an issue. So every time that somebody adds a new test score, I've got to change how far I go? Yeah, maybe. Okay, what we're going to do is take a minute. Okay, the program works. I'm just going to print something down here. All right, print test scores. Okay, this is not a trick. Okay, all it's going to do is going to show you all the test scores right at the beginning, and then it's going to do the loop. Okay, I don't care about the loop right now. I just want the first line. All right, so that's nothing weird, but in the world of strings, we had a function called len. And yeah, it actually is, the len function works with a whole bunch of different types of things, including lists. It also works with strings. And what does it tell me? What do you think?
The length.
Yeah, the length, which of course is the number of items. Okay, and take a look at that. So you know that there's 10 items. Ah, perfect. So instead of saying this one, I can say length test scores. But remember, this is going to be one more than it needs to be. So remember our deal with the counted loops. Quite often we start something at 0 and we say go, well, it's less than the maximum number. There's exactly the reason why we do it. Okay, so now if we remove this print statement, here you go, that's fine. And notice that if somebody comes along and sticks in another score, it automatically works. Okay, but that's really, really convenient. Okay, all right, so there's our first thing. Now, why would we want to do things like this? Okay, maybe I'm interested in certain types of scores. Like, for example, maybe I'm really interested in I want to find out which scores are not passing scores. All right, no problem, use an if statement. And we can say if the test scores at index, say, is less than 60, then what we can do is we can print it. Okay, and take a look at the result of this. You see, now I'm seeing only the failing scores. Or maybe you're interested in scores that happen to be A's or B's or C's. Yeah, okay, so yeah, we can learn how to process things. All right, so we will be doing lots of stuff like this. Oh, but I have to do one extra item as well, and that is, I have to put an equal sign in here. Okay, because this one will end up causing you a whole lot of trouble. All right, yeah, I set it up. I'm going to loop through. I'm going to do everything. But for some reason, somebody decides they want to start from 1, and they remembered from my counting exercise, the counted loop exercise, oh, we start at 1, we go less than or equal to the maximum number. Perfect, right? Because a loop that starts at 1 and goes, okay, let me put this back. So how many items are here? 10, okay. Oh, do you think there's a problem? Like just in front of my cursor, you notice something? Yeah, there's like an extra comma. Problem? Not in this language. It's actually completely allowed. Why? Because people are lazy, and the programmers have basically allowed you to continue to be lazy. Okay, so extra commas are okay. 2 of them, that's a problem. But an extra comma at the end, yeah, they kind of let it slide. All right, so the loop should go around 10 times because it starts from 1, goes less than or equal to 10. Okay, so what happens when I run it? Does it go around? Is it a problem? Ooh, okay. Wait a minute, something's not quite right. Okay, you know what? To make this a little bit easier, let me trash my if statement. Okay, let me trash the if statement, and let me clear this and run it again. Okay, so my first question is, did it go around 10 times? I see 1, 2, 3, 4, 5, 6, 7, 8, 9. I only see 9 of them. It was close, but it didn't quite make it. And then it blew up and it said index error. Well, index error simply means that I asked for a position that was too big. Oh, did it print? So in other words, it ran into a problem. Did you notice anything that didn't get printed? Yeah, it skipped the first element. Okay, so there's a bit of an issue. It skipped the first element. And the reason why it skipped the first element is because, of course, I started from index is equal to 1 instead of 0. Why did it blow up? Well, it blew up because what's the biggest value of index that I get? Well, it'll be 10. Okay, and the problem is if you ask for test scores at 10, That's one beyond the end, and that will be an out of bounds exception. This type of stuff happens all the time. Here's the way how I debug them. And honestly, this is how I fix things. Sometimes if I don't have access to a good environment and I can't spot the error. Okay, you've seen me do this a pile of times, and yes, I will continue to do it. I print the index first, and I'll even stick in the word index, comma index, just so we can see it. Index 1 was no problem. Take a look at that. The very last one, index 10, bang, it blew up. It somehow or another managed to print the value 80, but what ended up happening was it blew up on the next attempt. Okay, so it's something you have to watch out for because hey, these types of things happen. All right, now we've got to do a couple of extra things in here. I know it's not in the list, but I'm going to do it anyway. All right, I'm going to start from 0. Okay, I'm going to start from 0, and okay, it is not a, oh, sorry, and I'm going to make this less than because that's the pattern that I taught you for counted loops. There's a reason for it. When I run this version of the program, okay, it's not a trick question, how many print statements do we see? Here, let me, how many test scores do we see? That's a better question, or better, yeah, it's a better question. 4? I think it'll be all 5. Okay, it's not all of them. The highest index it goes to is 4. Okay, so the first 5. All right, that's excellent. Sorry, I want to show you something that's very, very cool, although perhaps disturbing. You see, the thing that shows up inside the square brackets can be anything. It doesn't have to be just a fixed variable. So what am I doing here? Well, think about this. When we did these input statements, please enter test 0, test 1. By adding 1, you're really getting the next item. Okay, so this is an offset from an index. We do use this sometimes when we're comparing things. All right, so this is not a problem, it runs, but take a look what we end up getting. Notice that the first thing that it showed was 80, and it skipped over the 70. Well, that's because index was equal to 0, so we actually asked for the next item. You see, sometimes it's going to become really, really important because sometimes you want to know, is the next score bigger than the current score, or is it less than the current score? Okay, a little bit more involved. You'll see some of that in the labs. Okay, just while we're here. All right, somebody will usually at this point yell and say, isn't there an easier way to do this? Because remember, I showed you something called for loops. Yeah, so can we use a for loop for a list? And the good news is, yes, you can. To a point. Okay, now what did I put 2 of them? This is completely fine. I'm going to show you 2 different ways of going through and printing the scores, but to make it a little bit more interesting, I'm going to print only the passing scores. Okay, so only scores that are bigger than 60. Okay, just so we've got a fair game on this. So here we go. Now remember, for loops would normally work as, well, for something in something. Okay, I have no idea what. And all I'm going to do is I'm going to start by printing, and once again, yeah, don't copy X. This is just for me. And what I want to do is I want to say for test scores. Remember, if test scores had been a string, we know exactly what this does. This would print out each character and, of course, then print it. When test scores happens to be a list, it works exactly the same way. It goes through each of the items in the list and pulls them out one at a time. Okay? All right. So that's often called the loop variable. Okay, so X is a loop variable. Now, it's not a very good name, X, because what is X? X is one of these. If you had to describe, if I asked you what's being printed, you would tell me, what would you call the number 70? The grade, okay, I'm fine with that. Okay, here we go. So we'll call it grade. And grade. Okay, excellent. I would have taken score as well. It would be very bad to say it's an integer. I mean, I know that's the type, but this is going to be a little bit better. Okay, there's a question, so I'll see if there was a question or answered. Okay. Oh, okay. No. That's actually not something we see, is it? All right, final scores. Okay. Anybody know what AB stands for? It's absent. That's what happens when you, if you end up missing a final exam, this is what gets recorded in your transcript until it gets changed for the deferred exam. All right, so excellent. Is this allowed? And the answer is in Python, it is. Okay. Yes. Most of the time, we will be using lists of integers. That'll probably be our most common thing, but they can be a list of anything. They can be a list of strings, or if you want, you can have a list of mixtures of things. So you can have integers and strings, you can stick in doubles, you can stick in anything. You stick in bools, you can have nuns, you can even have lists of lists, but not today. Okay, all right, so just to let you know it's here, let me remove this for a second. I will put it back. Okay, I said I was only going to print the passing grades. Okay, so here we go. If grade bigger than or equal to 60, print it. There you go, there's passing grades. Okay, so now we're iterating through, we're processing things. Now, what happens if I stick in an AB? Is that a pass? Definitely not. Okay, it's definitely not a pass. That just means that somebody hasn't written the final exam yet. I can't consider them a pass. They're not a fail either, but they just shouldn't be counted. All right, so in other words, when I run this, I better not see the AB. Okay, so here, clear the output, and just in case it does work, and here you go. I suppose the good news is we don't see it. I mean, AB is not printed. Unfortunately, the bad news is it's a type error. All right, here's the problem. Remember that the very last time I went through, the loop variable called grade picked up the string AB, and somebody asked, is the string AB bigger than 60? And sorry, you're not allowed to do this type of conversion. Okay, you're not allowed to compare these things. All right, one of the comments that I had in the previous slide was you can have mixed types inside a list. It is allowed. However, the downside is it makes the programming really difficult if you're going to support different types of items like this. Very, very tricky business. I could actually put all of these things into strings and life would be a little bit easier, but it's going to cause some other issues, so not today. All right, so what I'd have to do is I'd have to literally ask what type is grade, and if grade's an int, then I process it. If it isn't, well, then maybe ignore it. Okay, but we're not going to do that today. Okay, that's not the purpose of the day. We have other things. Lists are difficult on their own. So in other words, what you really want is you want to make sure that I always give you all of the same types. It makes them something called a homogeneous list, which means that everything is of the same type. It does make your life easier. Does that mean that it'll always be like this? No. There are some possibilities where you might put certain codes in, but then we'd have to learn a technique for getting rid of them. And we don't have that technique quite yet. Yeah, we'll eventually get there. All right, that's one solution. Okay, you know what? You've seen me do this before. Okay, there we go. Oh, and I'm going to get rid of this one. No, not this. Okay. All right, just a comment, just so you can compare it. Okay, let me do it again. For loop. For. Okay. For index and range length test scores. Ooh. Okay. The stuff that I just highlighted, that's a length function. When you call the length function on test scores, what's the number that gets returned? Yeah, the number of, how many items are there?
10.
Okay, good, 10, not 9, 10. Yeah, 5 plus 5. Yeah, there are 10 things. All right, so no, it doesn't stop one before. I'm just talking about the highlighted thing, okay? The highlighted thing is definitely 10. All right, if I said for index and range 10, and I print the index, what do we see? What's the first number that comes out? 0. What's the last number we come out?
9.
All right, 10 and a half. Okay, 9.5 because of the average. It's 9. Okay, remember, it doesn't include the very last number. Oh, but that happens to be exactly the indexes. Okay, so now that I have the indexes for the list, what I can do is I can start asking questions like this. If the test scores at the index is bigger than or equal to a 60, I will print the test scores at the index. There you go, there's the passing scores. Okay, oh, so we have two options. We have the first option, okay, we even have the second option. Yeah, they can both be in the same program. Hey, there's no These are not incompatible with each other. So here we go. Close. There you go. There's the. It's not a before and after, but it's the stuff before the line, the stuff below the line. All right. So yeah, they both work. Okay. Use them interchangeably? Sure. Almost, for this purpose. Okay, but only for this purpose. All right. How many people? Okay, so given a choice, if I ask you to print out all the test scores, how many people would go for the first one that I just finished? So I'm talking about this one right here. How many people would go for this one? Anybody? How many people would go for the second one?
Okay.
Yeah, you see, yeah, everybody wants to say, why? It's shorter, of course. I mean, and I've said this before, programmers are incredibly lazy, so yeah, of course you'd always go for the shorter one. All right, and yeah, this is completely fine. However, the first one is required sometimes. Okay, the first one is required sometimes, and that is for using an index in range. Okay, so let's put this into a perspective. So I'm sorry, I'm going to skip around a couple of slides. What did I do? Modification. What did I do? Okay, fine for time. Okay. All right. Oh, test scores. Okay, I assume nobody wants a failing test score, right? Nobody ever says, yeah, I want to keep that 50. Everybody will come and they will ask for me to change it to, well, at least let me pass, right? Okay, so let's do it. Let's take everybody who has failed and we'll give them a 60. Oh, I mean in the program. I don't mean in the course, sorry. I won't be able to pull that off. I get into a whole pile of trouble. All right, well, take a look at this. Obviously, it requires that I have to go through and do a bunch of things. Okay, so here's what I'm going to do. Oh, I shouldn't have erased everything. For index in length, or sorry, range length of test scores. Okay, here we go. We're going to ask the question. If the test scores at index is less than 60, remember what I can do is I'm allowed to change the contents. I can actually make it exactly equal to 60. All right, and what if it isn't? Okay, well, they've already passed, so who cares? All right, at the very end, print test scores. I'm just going to print the entire thing. All right, so here we go. Oh, just for comparison, I'm going to print the test scores before, and then I'm going to run this loop. I'm going to print it afterwards. Okay, so take a look at this. This makes it a very good visual separation because you can see the before and the after, just one line after another. And you can see that, hey, look, the 70 was left alone because this if statement was not true. But you can see that the 45 became a 60, the 12 became a 60. Maybe you put a limit on this. The 50 became a 60, the 50 became a 60, the 80 stayed alone. Okay, so yeah, this is going through and modifying an array. Or sorry, modifying a list. Sorry, I said I would use the word array occasionally. It's going through and modifying a list. So what I've done is I've started at the very first item and I said, okay, if it changes, or sorry, if it's below the threshold, which is 60, make it 60. Okay, do people do this? Well, not for this purpose. Okay, we know we don't go through and run this. But there are cases where it is legit. Like, for example, what do you think about that one? I know everybody would probably like to have that as a grade, but guess what? That's going to cause a whole pile of troubles. So that number, even if they calculate, because I don't know, get some bonus or something was dropped or whatever, that number shouldn't actually exist. What should it be at most? 100. Okay, that's called clipping or capping. Okay, this is exactly what's happening in the slides as an example. The other one, of course, would happen. I guess nobody would probably want that score either. Okay, but what's the lowest legitimate score? Zero. So maybe you've got a bunch of penalties and you just cut it off. So these types of things, that's exactly the question that we've got. Okay, on the slides, it's exactly the demo. All right, well, let's pretend it's not here. We're just going to be nice and we're going to pass everybody. All right, so there we go. That's one approach. All right, nobody likes this one because you like the for loop instead. Okay, so let's do the other version. So remember how this works. Somebody called it grade. Said for grade in test scores. All right, first of all, I'm just going to print it. Okay, just to remind you, I can see all the scores. Okay, there's no problems with this. If grade is less than 60, print it, okay, again, these are the scores that are below 60, so these are excellent. So your expectation now is, okay, what if I wanted to change the score? Okay, well, it seems like all I should have to do is just type grade is equal to 60. I mean, that's exactly what we did a second ago. Okay, so let's see. Did we manage to pass everybody? And the answer is no, it didn't actually make a change. Okay, here's a problem with for loops, not involving indexes. The variable that you get right here for the grade, whether or not you can change it depends on whether or not the variable falls into a category called mutable. And at the moment, integers are immutable objects, which means you can't change them. Okay, so, but if you keep this in mind, you say, okay, whatever comes in a for loop for the variable, you can't use it to modify things. Sorry. If you wanted to make a modification, you have no choice but to go the other approach. So you don't like it, but sometimes you have to use it. So if you're looking to modify something, you have to do the harder loop. Okay, and trust me, I do too. Okay, or you do something completely different, which I can't remember whether or not I've included in this slide or not. Okay, let me see which one. I'm just trying to make a decision about this. Here we go. Okay, I'm just going to steal a piece of code. Okay, the full description is in here. All right, and what this is doing, okay, I've got this I've got a variable called increase and it starts at 0, and you can see sometimes I add 1 to it. Yeah, this is called a counter. We did this before when we were counting how many tests were passes and how many were fails and so on. Yeah, this is exactly counting. All right, and what is it counting? Well, it does something very strange. It goes and it checks to see whether or not temperatures at I plus 1 is bigger than temperatures at I. Okay, wait a minute. Okay, and of course it's going for I should have used the word index actually, so I'll update my slides. And it's going through all of the items. It says -1. Okay, we'll come back to that in a second. You see, what it's doing is when I is equal to 0, what we're really doing is we're asking whether or not this number is bigger than this number. Okay, and then what we do is we add 1. So yeah, so in other words, what we're doing is we're comparing two values at a time. The first time through the loop, I'll be checking 0 and 1, and I'll ask, is the temperature at 1 bigger than temperature at 0? Yes, it is, so it goes up by 1. I then repeat it because I add 1, and then I'm asking the question, is 1 and 2? Is number 2 bigger than number 1? And the answer is no. So what I'm doing here is I'm counting how many times the increases happen. So it doesn't happen here, but it does happen here, and it does happen here. So this will be a total number of 3. Okay, excellent. Now, the reason why I've included this is, can we do this using the other style of loop? Can we use a regular for loop, like the for value loop is actually what they're called? Let's just think about this for a second. For T is an okay temperature, I don't mind that. For T in temperatures, okay, I can print it, that's printing everything, but here's the problem. Can I compare this T against the previous one or the next one? And the answer is no. All right, so there we go. There's another reason. You cannot use a for value loop, like what I've done here, if you need to compare two adjacent elements or you're trying to change something. Those are the two reasons. Otherwise, for printing, no problem. Now, the good news is most of the time you'll probably find that this is sufficient for a lot of the stuff, but you can't just say this is the only one I need to know, because you might get into a situation where you need the other one. Okay, we do 45. Okay, we're fine. Okay, next page, we've done this. Okay, let's get some things over here. Okay, I'm going to use the example from the slide. Sorry, it's a little bit boring, but that's fine. Okay, I got a very simple question to ask you. Does the list of temperatures include the value 29? Yeah, it does. Does it include the value 45? No, okay, that's a pretty simple question. How do we write code for this? Okay, so what I'm going to do is let's have here, I'll copy and paste it. what I'm going to do is I'm going to ask the user to enter something, and I want to find out whether or not it's there. Okay. All right, now, here's one way of doing it. There you go. That's one way. Okay, what I'm doing is I'm just going to go through each one and find out, is it there? All right, so let's find out. Let's ask for the number 32. Okay, is it there?
Yes.
Okay, so it should find it. Yeah, excellent. And if I ask for 88? You know, it shouldn't say anything. Excellent, so that's a way. Yeah, you can iterate through. Oh, but of course you could also use an index loop. Okay, for index in range length of temperatures, that's fine. However, we actually have something very, very nice, and yeah, it's actually something that you've seen before, and that's the word in. We saw this inside strings. So we can ask temperature, okay, I'll just print a yes, otherwise I'll just print a no. Okay, there we go. So yeah, just like a string, you can ask whether or not something is there. So I'll ask, is the number, let's see, do something different. Is 29 there? Yes, it is. And the good news is, okay, this is your fault for not telling me I had a spelling mistake. Okay, let's try again. 29. Okay, excellent. And 77? Yeah, of course not there. Okay, excellent. So you don't need a loop for that. Yeah, that's actually right. You don't need a loop for this thing. Okay, if you're looking for a particular value. Now, if the question was, are there values between 34 and 40, that I can't use the in function for. Okay, in this case, you would have to actually iterate through. And yes, when it comes to test questions, I don't ask for simple things like this. I ask for the more difficult ones. So, sorry, it ends up happening. All right, that's one question is it there? There's another sort of similar question, which is really quite interesting, and sometimes we need it, is where is it? Okay, now what do I mean by where is it? Okay, so let's go back and I'll ask the question again. Is 29 inside my list?
Yes.
Yeah, where? What position? 3, okay, index number 3, excellent. So there is a function, temperatures, well, it's actually a method called index, and you can pass in to find, and we'll print out the location. And what it will do is it will find out whether or not something is there, and if it's there, it will tell you exactly where it is. Okay, so let's run it. So if I ask for 29, everybody yelled out 3. Okay, that's good. If I ask for a position, or sorry, the number 28, yeah, 0, okay. Oh, since we're here, if I ask for the number 25, 4, can I hear -1? That's what I was.
It's working, but it's not showing.
Yeah, okay. So first of all, 0, 1, 2, 3, 4. So it will be 4 if it's found, or it's a -1, but no, it does not return a -1. Okay, so no, it doesn't work this way. It returns only the positive one. All right, so here in that case, let's ask for the number 45, and is it there? Okay, so what's its location? Okay, it's not in the list. Okay, that's actually the best answer. All right. I'm going to describe it as older programming languages because they really were, but other programming languages, sometimes if something isn't found and you ask for a location, it might come back with the location -1, because in a lot of other languages, -1 is not allowed. But you can't do it in Python because it means the very last item. All right, here's what happens. Nothing good. It shows up as a value error. Okay, so if you try to find the location of something using an index, this is what you end up getting. If you really want to use that to figure out where something is, you have to use it this way. Okay. All right, so this one right here, there, we'll ask for the 45. Yeah, I see no reading found. You notice what I had to do is I had to use an if statement first to find out whether or not it was there. Sorry, if you want to use index, you have to make sure the item is there. Otherwise, your program crashes, okay, with a value error. All right, how are we doing? 10 minutes. Okay, no problem, no problem. 3 slides. I think we'll probably do it. Okay. Oh, finally. Okay, back to some temperatures. All right, there was a question way back saying, hey, if you wanted to add one extra item into your list, is it possible? And the answer is yes, and don't worry, we're going to see this a million times. There's an operation called append. Okay, so there you go. And what I will do, let me print temperatures before, and I'll print temperatures after. So we'll see two outputs, one before, one after. All right, and what the word append does, append simply means to take the value that was just put there and stick it at the end. Okay. All right, useful? Oh yeah. We're going to be using this a whole pile of times. Why would we be using this type of thing a whole pile of times? Okay, well, we'll get to that in a second. I think it's the next slide. Let's do something else, just because we're here. There's also an operation called remove. Okay, excellent. And, okay, take a big wild guess what this does. Removes the number 32. Let's find out if that's what happens. Yeah, okay. Notice that. Did it change any of the other order? Nothing else changed. It's all the same. It's just the one value's gone. Okay, that is an ordered property, by the way. If this was an unordered collection, it's hard to say what would have happened. You remove the 20, you remove the 32, and maybe the 25 takes its place. We have no idea. But in the case of lists, it will always be exactly what we expect. Sorry, we need to remove a 25 now. Okay, because we better figure out what this does. Let's clear the output. All right, I've got a whole bunch of options. Oh, yeah.
Can we print without the brackets?
Can you print? No. Yes, you can, but you'll have to print it yourself. So you'd have to set up a loop and go through and print it without the brackets, if that's what you want. This is the default. It just shows up with the square brackets. Very useful for debugging. But if you want it to look differently, you write your own loop. Okay? All right, this one here, remove 25. But there's two of them. Okay, so option 1, remove the first 25, remove the second 25, remove all the 25s, or blow up and say, yeah, there's a problem because there's more than one. What do you think?
Maybe the last one.
Oh, you should never go for the errors just because I said there's an error. No, that almost never works out. All right, so based on this, what does it look like it's done? The first one, that's exactly it. The same thing is true, by the way, for the index. If you ask for the index of 25, it would tell you 1 before I removed it. It will always find the first one and it'll say that's it. What about the others? Not my concern. You just ask for the index. Okay, so it will say, well, here's an index here. All right, so the remove operation works this way, and sorry, oh, come on.
So if you want to remove the second, the 25,
Oh, you want to remove a second one? Okay. No, Control Z, Control C, and paste. There you go. Now they're both gone.
no, keep the first one and remove the second.
You can't. Not with a built-in function. Is it possible? And the answer is yes. You would have to first of all figure out where the second one was, and then you have to use a different operation. Okay, but that means that you'll have to find the second one. But you can't use index. Yeah, that actually makes a pretty decent mid question. Thanks. But I can't use it now because now I've said it, but I'll keep this in mind for maybe next semester. So if you take the course next semester, maybe that'll be a question. I don't recommend like just taking the course next semester. Okay, so there we go. There is sort of some removal stuff. I don't want to go in and do too many items. Okay, yeah, I guess there's something we better do here. Okay, I see it isn't on the slides, but we may as well do it since somebody has asked. All right, they're sort of asked. All right, there's an operation called pop. Okay, what do you think the operation does?
Duplicate it.
Okay, it removed something. Okay, here. I think with 2 examples we might have it. Yeah, it removes the very last item. Useful? In data structures course, yes, we do this all the time. In this course, I'll be honest, don't use it that often. Okay, but it's here. It's not even in the slides. The reason why I want to do this is because somebody asked about removing a particular item at a spot. Okay, I'm going to stick a number in here, 2. Okay. And let's run it and see if you can figure out what it did.
You remove 32.
I removed the 32 because 32 was in position
Index
2. Yeah, that's exactly it. So if I really wanted to get rid of this one right here, the second 25, what would I use for a pop? 0, 1, 2, 3, 4. You could either use a 4 or you could use a -2. Okay, whichever one. So there you go. So that's how you'd actually remove it. But you'd have to know where they were first. Yeah.
So what's the difference between
Pop and remove. Okay, so temperatures dot remove 28. Comment this one out. All right, what does it do? Gets rid of the 28. Okay. What will that do? What will it attempt to do? It'll try to remove the element at position number 28. Is it there? No, that'll be an index error. That's the difference. So the remove removes a value, the pop removes a thing given its index, okay, which means you have to know the index. All right, ooh, now I'm starting to run a little bit out of this. Okay. I'm trying to decide which one I want to do. Okay, perfect. All right, here's a programming pattern. And yes, we're going to be doing piles and piles of programming patterns, and I will refer to this one as a very, very common thing. All right, here we go. What we're going to do is we're going to, okay, I'll reuse the same example that I've got here. So here's my code. Ask the user to enter 5 temperatures, and put them into a list. Why would you want to put them into a list? For further analysis. Okay, what do you mean further analysis? Maybe we're looking for the biggest, maybe we're looking for the smallest, maybe we're looking to put them exactly in order from smallest to biggest or biggest to smallest. Maybe you want to calculate the average. And yes, all of those things that I just described, you can almost do these things without lists. But there's going to be a lot of things that we can't do without lists. All right, this is a very, very common pattern. Okay, so here we go. 4, counter in range 5. Seen this all the time, right? So here's what we're going to do. Temp, int, input, temperature. All right. Ooh, unterminated string. Okay, here we go. So temperature. Okay. 5 working, yeah, that's fine. But of course, this is just gathering the values. All right, what we want to do is we want to be able to put these into a list so that we can do things later. This is by far the most common pattern that we're going to see in this course. It will come back, you'll see it at least every lecture from here until the end. You see, we might want to have a whole bunch of temperatures. And if we want to have a list, one very common thing that we do is we start with an empty list. Okay, so before we start the loop, we start off with absolutely nothing. Inside the loop, what we're going to do, here we go. Inside the loop, we're going to take temperatures, and of course now I've shown you the operation called append. What does append do? Add something to the very end. I'm just going to go and I'm going to add the temperature, or the temp, sorry. At the end, I'm going to print temperatures. Okay, so there you go. I would call it list building. Okay, it's building up a list. We start with nothing and we keep appending whenever we find things that we're interested in. Small modification to it, just to give you an idea. If the temperature is bigger than 45, do this. What am I doing? I'm building up a list, but I'm only interested in a few things. So for example, the 23, the 45 would not go in because it's right on the edge. However, the 76, the 54 would, and the 12 wouldn't. Okay, so this is a very, very common pattern. As I said, you're going to see this every lecture from here until the end. Okay, start with nothing, and keep building, keep building, keep building. If you were to come and watch my lecture for my Web Tech 2 students, you'll see me doing exactly the same thing over and over and over again. It's a very, very common pattern. You start with nothing, you build it up. We do it quite often in that course with strings. We start with nothing and we build up a web page one tag at a time. Okay, but that's for the other course. But you're going to see this happen many, many times. It's the most common pattern of program that we have. Okay, and what do we have in here? Ooh, okay, so what I'm going to do is I'm going to grab this very last function. I'm not going to spend too much time on it because I know I'm pushing my luck in terms of time. All right, because, hey, if you're interested in Cahoots, I've got some fun ones today which will cover this stuff. But here you go. This is the program that I've got in the very end. Do we recognize some stuff? Well, I hope so. Okay, this one right here. I hope you recognize that. That's what I just did. So the piece that I just highlighted, what's it doing? It's asking the user for five temperatures. It's pushing them all in. Okay, excellent. And then it's also asking, okay, what is considered to be a hot day? Okay, so maybe you put in 23 as being a hot day. And then what I'm doing is I'm calling a function. Oh yeah, lists and functions, they certainly work together. But take a look what it does. It jumps up to here to get hot temperatures. I have the readings that were done, and I also have the limit. What am I doing? There it is. It's the same string building approach. I'm starting with an empty list. I'm going through and I'm finding if things are of interest, I'm appending it, and then I'm returning at the end. So the result is something like this. So here we'll toss in a couple of values, 23, 70, I guess that would be a hot day, and a 30. And if you say, what's a hot day? Okay, if we said like 35 is a hot day, it goes through and it figures out that, oh yeah, there happens to be two of them. Take a look what it did. I built up this list, one item at a time, and there was exactly two things in here. And if you take a look right here, I printed the length of hot days. This is the type of thing that we use lists for, to gather the information so that we can measure things like how many items happen to be inside that list. Okay, and this is really kind of just the beginning of what we will do next class. Okay, and I think that's the whole reason why it's here. All right. So if you're interested in a bunch of really difficult problems, okay, yeah, let's try one of these. Okay, so once I get this over here, here we go. So yes, one of these horrible things again. Okay, go for it. Okay, so we know that it's 44, and I know I don't have more students than this. So if you want to work with a neighbor, that's completely fine. If you want to work on your own, that's also okay. Okay, what do we got? 35. Okay, there's enough room for 10 more. Hey, that's cool. It's all white. Okay, any more? Okay, there we go. Okay, here we go then. All right, off we go. All right, so, I mean, if you're not participating, at least sort of watch along. Most of them are in the forum, what's the output of this program? Don't worry, it's all pretty simple. They're only like 2 or 3 lines this time. But you can do a lot of stuff in 2 lines. 38. Okay, we'll find out in a second. Okay, there we go. Hey, excellent. Okay, a few people went after the 10, and also the index error. Oops. Okay, we better just take a quick peek at that one. All right. So remember the stuff right here from length of values. That's a function. What is length of values? In this case? Yeah, it's 3 in this case. So I'm asking not just a general, but it's 3 in this case. 3 minus 1 is 2, and the values at position 2? 15. Okay. All right, but I mean, most people got this, so good. Seconds more. There must be 2 more. Okay, good. Here we go. Okay, very good, very good. Okay, so just a quick review of that one. All right, so remember, length of values. Length of values this time is 4. And the values at position -4, well, that will end up being the very first element of this or list because there are exactly 4 elements. You have to watch out for that because it may have been too big or something. All right, but that's good. Okay, next one. I told you they were easy. Okay, so I didn't make them hard enough. I'll fix them for next semester. Okay, that one didn't work out so well. All right, a bunch of people have gone for the 78, 0, and 100. Okay, remember, when you're using a value loop, you can't change the contents, so therefore you're not actually modifying scores. So scores remains exactly as it was, the 78, the -5, and the 105. Okay, if you wanted to change them, you have to use an index. Okay, all right, so it's sort of as expected, actually. At least you got one that got a bad result. That's what I'm always trying, is really hard ones. Okay, so let's see if you can think about this one. Oh, and yeah, slicing in lists works exactly the same way as it does in strings. I forgot to cover that one. I'm glad I put this in here. Oops. Okay, so as I say, sorry about this. It was one of the things that make sure it gets put into the slides. Yes, slicing works exactly the same in lists as it does in in strings. All right, so in other words, if you were to say square brackets 2 comma 8, what it will do is it will pull out elements 2, 3, 4, 5, 6, and 7, but it won't include 8. Okay? All right, so first thing up we have data at subscript 1:1. Ooh, what is that? That means start at 1 and stop right there too. But don't include 1 because it's at the end. So in other words, it's an empty list at this point. Okay? Yeah, trick question. It's not a trick question. Okay. But anyway, yeah, it's quite understandable why you'd go for this one. Okay, so 3 more. 3 more, then we'll be done. Okay, sorry, we'll be a couple minutes later than usual. All right, well, hey, this question was asked earlier. Now the question is which is it? Or is it pop? Oops. Is it pop that uses the index or remove? Okay, good. All right, so well prompted from earlier then. Yeah, remove removes the first value. So the first 30 would go away and you'd end up with a 25, 30, 20 at the end. Okay, 2 more. Okay, this one's a little bit different. What happens when the code is run? Sorry, the blue diamond should probably say the program prints 369 and finishes normally. It's a pretty flat response. So in other words, you had no idea. No, that's what it means. All right, so the program prints 6 and 9 and crashes. Yeah, so remember, we've got a total of 3 things. So the loop says, well, I starts at 0, while I is less than 3. Okay, that's fine. But then the issue is this I plus 1 business, because we're stepping 1 step ahead every time. So when I is equal to 0, it works. You'll print the 6. When I is equal to 1, you'll print the 9. When I is equal to 2, you're off the end of the array. That's an out of bounds. Okay, so that's the crash. All right, final one. Then we're done for the day. Sorry, being a couple minutes longer. Okay, how'd we do? Good. Okay, excellent. All right, and of course the thing here is that if you try to access, so is 30 in temps? Yeah, it definitely is. But when you try to access temps at position 30, I mean, that's obviously not 30 items here. Okay. All right, so here you go. We can see who ended up at the end. They're all pretty close scores. Okay, congratulations, whoever that is. All right, thanks, and we'll see you Wednesday.